you for joining us for the MetTrans Consortium seminar. And I know that some of you are here with us in the room and some of you are with us on Zoom, and we're pleased to have all of you. And I'd like to welcome Dr. Kari Watkins to campus today. Kari is visiting us from UC Davis, where she is an associate professor. Kari is affiliated with the National Center for Sustainable Transportation. MetTrans is a partner in that national center. And so we're thrilled to be able to offer this seminar. I think we're trying to claim this as we promised to offer one NCST seminar per semester. And I think Kari, we're counting you.
Okay.
Kari did her Ph.D. at the University of Washington, was a professor at Georgia Tech, who very recently moved to take her current position as associate professor at UC Davis. Kari's primary areas of research are on transit and on bicycling. And for transit, her dissertation, she developed the One Bus Away software, one of the first pieces of software that would give users real-time information on where the next bus was. Very, very innovative at the time. We're about
years ago.
Yeah, but she's continued that tradition of innovating. I am a fan of titles that convey a lot of information. And Kari, I want to thank you for this title because it tells you not only the topic, but it tells you a lot about where we are at and what we are learning. Let me turn the floor over to Kari Watkins.
Thank you very much. Thank you, Marlon, and thank you for having me here at USC. It's nice that we're getting back into this world of where we do these things in person. So I get a chance to travel and actually meet a bunch of folks while I'm here instead of these Zoom sessions where it's just a quick talk and then you're off. So it's great to be here. And I will echo what Marlon said. I like to use provocative titles. I've been a long time cyclist, and I did start my research in the transit world. But being in Georgia, it was very difficult to be a cyclist in a place like that. And so I got more and more interested in research in the cycling world. So when Marlon gave me a choice, I said, I generally do my talk kind of around a broader picture of lots of transit research for the last 15 years, or a broader picture of cycling research for the last 10. He said, totally up to you. And I said, I'm going to talk about bikes. So thus you get this. So lessons learned in my desperate attempt to make it safe to cycle on American roads. I have worked in transportation for a long time. I was a consultant for 10 years before I went into academia and got my Ph.D. And so I've worked on many aspects of transportation. And what I've seen in these many years is that transportation has been causing a host of problems, all things we're very aware of, but just to set the stage so we're all on the same page. We've been causing problems like this, right? And like this. And even this. And this, right? All things that we study and talk about all the time, the link between the way we get around in obesity, this prevailing safety issues that we have. My husband works in aerospace, and he's like, good God, if our industry worked anything like yours, we would be shut down to have that sort of record of death at the way that we're providing roads, right? Pollution, looking at the climate impacts of the way that we travel, the congestion, the wasted time on a day-to-day basis. And one of the things I think that would help move us along to solving all of these problems. Many of the solutions we talk about on a day-to-day basis will solve one of these, a couple of these, maybe most of them, but all of the ones I'm mentioning right now are actually solved by us not thinking about cyclists like this, but instead thinking of cyclists like this. And there are actually a lot of people, study after study has been done showing that people want to be traveling in cities like this. They just don't feel like they can the infrastructure is not present, that they feel the risk of the roadway, and they don't feel that they can make a choice to be like my friend Rebecca, who was a fellow cyclist in Atlanta. And if you can't count, she actually has 3 children on the back of that bike. Something that when I take students to the Netherlands would not be an unusual situation. But in Atlanta, people would take pictures of Rebecca all the time because nobody saw people biking like this, right? So I'm going to talk about a couple of different things that I've done over the course of the past years to try to zero in on this problem. Things that I think mostly intuitively we've known for a long time, but we were trying to put a finer point on it. So the first of those is looking at perceived safety. So this was a study that we did a number of years ago for the National Cooperative Highway Research Program. This is a part of the Transportation Research Board. Many people know TRB is the big annual meeting conference that they have, but TRB also has a whole host of research programs where they hire either consulting firms that do research or academic researchers that do a little bit more applied research. And this was one of those. So through this NCHRP project, we were trying to broaden the understanding of what kinds of facilities cyclists prefer among not just current cyclists, because there's lots of work out there looking at what do current cyclists want to see, but we were trying to do this in as unbiased of a way at asking potential cyclists, so people who are not currently cycling but might want to, given if it was a reasonable trip in distance, et cetera, how do we build for them to actually feel like they could do this? And the way that we approached this was some of this work has been done in places like Portland or in Davis, but not much had been done in the southern United States, a very different roadway network, very different reaction from motorists to the cyclists. It was a place where we really needed to understand, okay, how do people feel about infrastructure and how might we make a change? And so we did this study largely in Alabama and Georgia. We had sites that were linked where there was new infrastructure being constructed, and we were trying to compare them to a case. So like a case control kind of thing. We had this case of new infrastructure being put in place, and we had these control cities with very similar demographics, like all of these variables that we cared about, except for the fact that the bike infrastructure was not being built. And we were trying to understand the differences there. And so what we did was we surveyed more than 2,500 individuals. We actually contacted 40,000 with a mail out survey. And they could either use an online link to take that survey or fill out the paper version that we had sent them. And we asked them their differences in perceptions associated with the type of bike facility, the number of lanes, and presence of on-street parking. And we were trying to understand not just what they preferred, but how did that change depending on the type of trip, depending on various socio-demographics, and even depending on their attitudes. So we sent them a bunch of images that look like this. We had many, many questions that said, in this particular situation that you're looking at, would you feel comfortable? Would you feel safe? And would it be something that you would try? Would you actually bike there? And so we asked them on this 5-point scale how they would feel about all of these different situations. And so here's an example of what one of these images might look like. We've got a buffered bike lane in this sort of parking with only 2 lanes of traffic situation. You'll see that we took sort of this neighborhood within Atlanta. Atlanta has a lot of a similar feel to LA, kind of a larger sprawling city of neighborhoods. And so we were trying to go with one of these, more urban cores of a neighborhood, but not quite a downtown. Could be mistaken for a small town like a Davis kind of environment as well. We took that and we only changed the bike infrastructure, the number of lanes and the parking in each of these various images. So you can see here we've done more of a cycle track kind of setting where we put the parking on the other side and the cyclist is closer to the sidewalk. And what we found was in comfort, in safety, and in their willingness to try, When we had very simple, like a Shero, this is the symbol that you've probably seen before on roadways, showing that this is a place where a cyclist could be biking. It's really about lane placement and letting the cars know a bike might be there. It's not really giving dedicated space for the cyclist. In that case, everyone felt below that neutral 3 on the scale, regardless of the situation that was occurring. And I shouldn't say everyone, of course, this is the average. We've got this distribution of how people felt. But when we got to a bike lane, if it was a 2-lane road with parking, then they did not start to feel significantly different from that. Actually, I believe it was significant, but the change is not that great. When you look at 4-lane with parking, it's a little bit greater of a change. When you look at no parking situations, if you put in a bike lane, folks start to feel comfortable on average, right? But it's not until you get to the buffered bike lane or some sort of a truly protected environment where there's some sort of a barrier between the cyclist and the roadway that people really, truly started to feel comfortable, safe, and willing to actually be out cycling. Okay? But we wanted to dig deeper than this. So we asked a lot of questions about their attitudes, about their socio-demographics. And the goal of this was we were trying to do exploratory factor analysis to condense all of these different attitudes about I like cycling and I'm dependent on my car and it matters a lot to me what my friends and neighbors think of me and how I dress is important. These kinds of attitudinal statements. We were trying to understand how those attitudes might play into how these might be different in those cases. And so we tried to put them into different latent constructs. And we observed 10 different factors that involved 28 of the attitudinal statements that we had. We also had those remaining 10 items. We either loaded them uniquely on one of those factors or they were weakly on many. And so we ended up removing those other 10 statements. The study that we ended up developing focused on 4 of those because they were the ones that, as we continued the modeling process, were the most interesting. We had this attitudinal factor that was about car preference. We had one that was about how much they enjoyed cycling. We had one that was about, we called it anti-exercise. So folks who were trying to more so limit how much exercise they were getting in daily things that they were doing, and risk tolerance. So how worried were they about the risk of things like cycling? And the way that our pattern loading matrix turned out, this car preference one was statements like owning a car is an important sign of freedom. I like traveling by car. It was negative with I am fine not owning a car as long as I can get one when I need it. It was our first concern for transportation should be helping cars get around. These all went into this car preference factor. In our bike enjoyment, we had, I like biking. I would bike more if people would bike with me. I like the idea of sometimes biking or walking instead of using my car. All of those things were positive. The exercise one, the statement was the importance of exercise is overrated, and then negative for getting regular exercise is important to me, right? And then finally, the risk one was taking risk fits my personality, and I like trying things that are new and different. So those were the ones that we ended up with. And when we then did our model, we had these dependent variables of our image responses. So we had responses to these images that I showed you again on this Likert scale, comfort, safety, willingness to try. And we put in explanatory variables of what was the type of bicycle facility. So we were using dummies for these different types of facilities that were represented in each of the images. What were the roadway characteristics? So number of lanes, presence of on-street parking. And then we had these framing effects. This is actually about, in the interest of time, I'm not going to talk too much about this, but the issue was the order that we had put the images in. There were some circumstances where we were trying to account for that to make sure that was not influencing as opposed to the image itself. And then we put in these attitudes and these socio-demographics. So first I'm going to show you guys where we went with what we call our pooled models. So these were the ones where we were focused on those socio-demographics. And then we actually did a latent class model that I'll talk about one of the ones. If this is something that interests you, I'm going to put a link to the paper at the bottom, and you can certainly ask me questions about it later if you have a chance to look up the paper. So where the pooled models went, we had decent for this type of effort R-squareds, and quite a few responses to go on. What we saw was that for comfort, safety, willingness to try, again, similar to those graphics that I showed, a bike lane got us some advantage over a Shero, a buffered bike lane a bit more. The one-way protected bike lane, so this is the bike lane, the protected bike lane along the roadway segment, as opposed to having both directions on one side of the road, which you sometimes see. That's what's called a two-way protected bike lane. That was actually preferred less, which is often the case because of driveways and such. Drivers don't know which way to look. So that actually played out even among people who don't bike. They understood that to be a less comfortable, safe feeling. And then multi-use paths actually were lower as well, sort of similar to that. So this notion in many of these communities, there was a path that was used predominantly by pedestrians. And so that difference between how bikes and pedestrians are using that path, and that you have to travel differently if that's the kind of dedicated infrastructure you're going to use. And then we looked at roadway characteristics. So you can see with our parking that it was negative, but the 2 versus 4 lanes, which was very surprising to us, did not make much of a difference. We thought maybe this was a mistake in the survey, and we actually had focus groups that we went out, and so we zeroed in on this. And what they said was, in places like the South, if it's only 1 lane, I feel like I'm stopping traffic. It's much more stressful for me, less comfortable. If there's 2 lanes, I feel like there's a place for them to go around. And so that really surprised us that people really sort of fell on either side of this, whereas the presence of parking was the kind of thing that was always seen as a negative, that they didn't like biking next to the parking. And then again, the framing effects that I'm not going to go too much into. So in our pool models, we included these attitudinal factors, and what we saw was the car preference was negative for all of these things. The folks who enjoyed bikes was positive. If they were anti-exercise, that was negative. And if they were risk tolerant, then they were, again, more likely to agree that these various settings were comfortable, regardless of which of them we were talking about. Makes sense. We also put in a lot of different socio-demographics, and interestingly, many of them were not significant. So it did not seem to have as much to do with various socio-demographic factors as much as it did these attitudinal factors, which is something that some of my mentors like Pat Mukhtarian are seeing occur in many of the models that we're developing to understand travel behavior. So having a driver's license actually increased the likelihood that they were going to feel comfortable or safe with the cycling infrastructure. As people aged, they felt less so. Many of the models, the female or the race did not actually show up as significant, but in the willingness to try, women more likely to say they would cycle, even if they said they were comfortable or safe, and white more likely, even though it didn't really matter what they said about comfortable or safe, they were more likely to actually bike it. So then we did our latent class models, and this shows you the class membership among these different attitudinal factors that we came up with. We also included information. We ended up in here with current cyclist and income were things that mattered in putting people into the different classes. What popped out though, we ended up with these 3 classes when we did our latent class model. And what really seemed to make a difference was these attitudes. That was what was putting them into one or the other, and this risk tolerance. And we ended up with these 3 classes. Sorry that the screen is over the top, but we ended up with the one we called our pro car. So these were the folks that had the higher car preference and the lower bike enjoyment. We ended up with 2 pro bike, one that was the risk adverse group and one that was the risk tolerant group. which is sort of fascinating because if you know anything about this literature, there's lots of folks that have been using this scale, the 4 types of cyclists for quite some time. And it goes from those people that we call strong and fearless all the way down to the interested but concerned. And this actually plays out in our latent class models. It absolutely showed up that what we were seeing is there was these sort of pro-car people. I would call that maybe our no way, no how folks, the ones who are probably not going to be attracted to cycling anyway. And then we have these 2 categories of folks who might be attracted to it. And some of them are going to be tolerant and they're going to bike in any setting, but some of them need a little bit more from this perspective before they're going to be willing to do it. And so what we saw when we looked at our models with each of these is how did they feel about the bike infrastructure? Well, I think I put boxes, there we go. What we saw was our intercept for the pro-bike risk tolerant folks was very high, meaning they didn't care as much about the infrastructure setting. They would take any of it, they were still gonna bike, right? They're saying, I'm still safe, I'm still comfortable, I'm still willing to bike, because on our 5-point Likert scale, they're above a 4 for their intercept, right? But they actually liked the infrastructure too. So it didn't make as big of a difference, but they still liked the idea of the protected bike infrastructure, which goes counter. There's a whole community in the bike world that really wants to, I hear giggling because he knows where I'm going, that really wants to see us integrating bikes in the roadway. And they say, if you can't bike with cars, you shouldn't be on the road. And so there's this long-standing debate between these 2 groups. And what this shows, if that was true, we would see negatives for these types of things, right? And we didn't. Even the more risk tolerant cyclists said, we like the bike infrastructure. We don't need it, but we like it. And those people who were risk adverse, well, they really liked it. They wanted to see this infrastructure there in order to feel comfortable, to feel safe. This was the safe one, but we saw very similar results in all of the models.
Kari,
Yes.
are these OLS regressions?
Yes.
So I can be reading magnitudes right off of the
Yeah, so the way we ran the models, we actually started with using OLS regression because it's a Likert scale. There is some debate around if you can actually do that because you've only got 5 values, right? So we ran other forms of models, and so our report, I think, includes all of the different forms that we ran, but the OLS are so much more interpretable.
Yeah, I mean, looking at this with magnitudes.
Yeah.
I mean, look, you know, and the infrastructure preference for the risk averse is larger than kind of the intercept of their baseline.
Exactly. So it's a very big difference.
It's a huge deal.
Yes, exactly. Wonderful. So where did we get to with this? When we finished the NCHRP report, there were many other things that were in there as well. But the conclusions that we had were that this separated protected facilities really should be a priority. This is how we're actually going to get people to bike in places. This is how my mother and me with my kids on the back of my bike are actually going to be willing to do this. We have to minimize the impact of parking adjacent to bike lanes. So thinking about which facility is going to be the bike-centric one, we actually don't want the parking on that facility. It made people uncomfortable. Some of our focus group things led to this idea that there needs to be a clear delineation between walking and biking on multi-use paths if you're going to have a large presence of both of these populations. Limited use of sharrows. They do very little for making people feel comfortable, safe. They really should only be a directional thing. They are not bike infrastructure. And then some of our things that we came up with that were sort of add-ons to this is the importance of having education or promotional programs, because these attitudes were so important. They really played into it. So if people see themselves as maybe I could be biking to get places, that made a very big difference. And then we didn't actually get great results from the part of the study that was about looking at the before and after. What we saw was people really liked the bike infrastructure. They thought this was great. In the time horizon of our study, we saw no travel behavior change, essentially. So our conclusion from that was that it's really part of a larger bike network. None of the facilities that were built were enough to really change dramatically most people's trip, because we were talking about a couple of mile long protected bike lane, and it's going to be a very small segment of the population that's going to make a difference until you build out this whole larger network. And finally, it is really important that we collect data in before and after types of settings so we can actually look at these things when we build them. So I'm curious about time. I just want to make sure I'm being cognizant because I tried to throw a lot in here. So if somebody could let me know if I'm starting to run too long. I don't see a clock. Oh, I got one right here. Okay. So this was this beginning notions of work that, others were doing, I was doing on looking at this perception. But part of it for me was about, okay, we know that people want this protected bike lane, but we're not going to be able to provide them in all settings. And is it really needed? In this cross section we had put forward was the kind of place where you needed it. But there are a lot of quieter roads with low volumes and such where people do feel comfortable cycling even in the presence of cars. And what is it about those facilities that makes that occur? Well, there's a mentor of mine, Peter Firth, who's long advocated this metric called the level of traffic stress, which is a great way to look at these things, except that it's not really based on much data. It's sort of an intuitive thing. If we have higher speeds, here's what would happen. If we have more lanes, here's what would happen. And so part of the next part of where we went with this research was trying to understand, okay, as someone's cycling, what is it that's making them feel stressed out? What is it that they want to see happening around them that makes a difference from one facility to another, other than just the bike infrastructure? So we started a project at Georgia Tech called Seeing Like a Bike. And so the whole idea of this was to use sensors on an instrumented bike so that we could actually sense what was happening around the cyclists as they were traveling and do various measures of how stressed they were in order to understand that stress level and what was it that was causing that stress level. We started this whole process with some funding through a UTC that was focused on air quality. So that was one of the first things that we did. We created what we call our slab boxes, so our Seeing Like a Bike boxes. And these had all of these different sensors in them, including some air quality sensors. And we put them on the bike, and this was our instrumented bicycle that we used. And so we could actually do this on anyone's bike. So if you came to us, we could attach these things on any bike, even your Brompton sitting in the corner. We would find places to hopefully attach these things so we could do our experiments. And in the front, we had a computer, an Arduino. We had various sensors in the rear component, which is the larger box, and a Raspberry Pi so that we could connect all of this together. And actually, I'm a very firm believer in open source coded tools. So all of like the instructions on how to set this up yourself, how to pull the data from it, all of this is all on GitHub, and I can point anybody to it who would be interested. The first thing we had to do for an air quality study, though, was to make sure these cheaper sensors that we were using on the instrumented bike were actually picking up air quality results at the same rate that a really expensive, high quality sensor like a GRIM would do so. So we did some initial testing of these things. We actually did not pick up the highest spike events that the GRIM picked up, but we still saw them as an event. So it was still, on average, we were getting pretty good air quality data, even if the spikes were not quite as big as the spikes should have been. So we moved forward with the study. And we did 4 different routes in the Atlanta area, all of which had different levels of infrastructure, different speed roads. We were trying to vary it substantially as you went through this route. And we had folks who rode each of these individual routes, depending on where they lived or worked, they could choose which one would work for them. And we measured our air quality on each of these routes as the first thing that we did. And you can see that for the most part, our air quality, we were looking specifically at PM 2.5, and most of the PM 2.5 was pretty good. We had segments where it was not, but for the most part, it was actually better than we thought it was going to be in most of these locations. What we tried to do here, though, was to look at the difference that cycling infrastructure made. And it did make a difference. You'll see in the next, let me flip to the next one first. It was actually just barely not statistically significant if we're going to use the 5% level. But it was getting close, right? It made a little bit of a difference. But part of the issue was that what made the biggest difference was commercial land use. So basically, when you biked past that restaurant that was using their air fryers extensively, we had such high spikes in our PM 2.5 that made a much, much bigger difference than the cycling infrastructure. So to a certain extent, we didn't get a chance to do so, but we thought about rerunning the study and purposely avoiding commercial locations because we had too much of a correlation between the commercial locations and where the bike infrastructure was, that it was really hard to tease these two things apart. But you can see we were seeing a little bit of a difference in where cycling infrastructure was. Major and minor roads made less of a difference, but a little bit of one. But this commercial land use was what really did it. In our models, you can see that the PM 2.5 having commercial land use adjacent to the roadway was what made a big difference. So our conclusions from this one. There was lower PM 2.5 exposure on these designated cycling facilities, but land use really made a bigger difference. The demand for bicycle infrastructure is greatest in commercial areas, so these two could potentially work together in some ways. But also the meteorological variables in the background made so much bigger of a difference than anything we were looking at with the bike infrastructure. That's kind of why we stopped the work, was we decided that the facilities themselves were not actually protecting you enough from the car adjacent to you. It was the quality of the air sort of everywhere around you that was making so much bigger of a difference. So that was kind of our interesting little one-off to get the study started. And then we moved into this area of cyclist stress. So we were trying to understand, okay, what actually stresses out these cyclists, right? We can measure their air quality. We don't think that was actually what was stressing out these cyclists, but it was a great way to get our instrumented bikes funded so that we could put all of these sensors out there and start doing the rest of the study. So one of the things that we did with all of this, we did routes in both Atlanta and Delft, because one of the students that I had working on this actually got a scholarship to go and study in Delft for a year and live in the cycling paradise of the Netherlands and worked with researchers there. And so one of the most fascinating things that we've done with this data is to look at differences in how stressed the Dutch are and in what various cycling situations, a place where they have lots of good bike infrastructure, versus Atlanta, a very different picture from what you see in the Netherlands. And so again, we took these example routes where we had people biking along them with very different infrastructure. So you can see it goes through, this is in a park, it's a wide trail within the park. We've got two-way cycle tracks on the side of one road that's fairly slow speed and medium volumes. We've got quiet residential streets. We've got a little bit busier streets with no bike infrastructure on them, a bike lane on the side of some, a busy 2-lane in each direction roadway with no bike infrastructure whatsoever. Another one similar to that. So we had a lot of different types, and we tried to do the same in the Netherlands. We tried to vary it as much as we could. It was much harder to find those parts of the route that had no bike infrastructure there, but we could find them there as well. And we had the participants do their route and complete this stress map where they were just telling us, here's where I feel stressed, here's where I feel less stressed, that type of thing. So we would have them stop periodically and color their map. And what we saw, which is not entirely surprising, is that they felt low stress on most of the routes in the Netherlands. In Atlanta, there was still quite a bit of routes where they felt low stress. But in Atlanta, we had quite a bit where they felt some pretty high stress levels as well.
Kari, these were these just people who bike in those cities normally?
We tried to recruit people who didn't necessarily bike all the time. So we tried to have a spectrum, I would say. We tried to find people who would bike frequently, who were less risk adverse. And then we tried to find people who were willing to do our study still, but who didn't necessarily cycle all the time.
Okay, because what I was thinking, if it is, to the extent you have everyday bikers in there, the Delft folks may, well, you've got some kind of bias, right? You just don't know what it is, but there's a difference no matter what.
So what's super interesting is what stressed them out, right?
Okay.
We say they're stressed, right? But define your stress. I think here we automatically go to the car part of the equation, right? But what we saw was motor vehicles stressed folks out. Well, motor vehicles stressed folks out in Atlanta a lot more than in Delft because the drivers drive differently there, but they still did so, right? Poor pavement was not a thing we were actually expecting. And lots of folks said in our surveys that the quality of the pavement made a much bigger difference in some cases, even than the infrastructure. And that was true in both. For infrastructure, big difference in Atlanta and Delft, they were less worried about it. So even when they were on roads where there was no bike infrastructure, we think it's really that the cars are behaving differently. But some of the interesting things in Delft, we saw other cyclists. So this thing that in the US, we can't even imagine how biking with so many cyclists around you could stress you out. It's a very different situation in Delft. They will come to a stoplight and you're surrounded by 10 other cyclists. And if you're a little bit newer of a cyclist, getting going in that is difficult because you might need a little bit of space around you to sort of push off. Being worried about how other cyclists are going to maneuver and can you react in time? These are concerns that we don't really think about, but in Delft were actually something that was stressing them out in various situations. Infrastructure, having quality infrastructure was a clear stress reducer in both places. Having low volume streets was a clear stress reducer. Having familiarity with their route was a big deal in Delft because many of our respondents were students. It's a big educational community. And so some of them were not from there and trying to learn their way around. And then speed differentials in the US. So our goal was to dig deeper into this. And we did a lot of different studies where we were using GPS from the instrumented bike to understand the difference in speed that people were going in both places. So you can see in Delft, they went lower speeds. And many of the cases in Atlanta, when we were combining sort of this data with these surveys, what people were telling us is it's not that they wanted to go these speeds, but they were stressed by the cars and they felt they had to. So we see this faster speed, not out of a desire, but out of a necessity. And the speed differential was really stressing them out between them and the car.
25 miles an hour on a bike is.
These are kilometers per hour.
Okay.
Oh.
Sorry, I should have said that.
I don't
Yeah. So, I mean, yeah, I'd have to do the quick conversion, but yeah, I mean, over there they use kilometers per hour, so we had to pick one of the two. And then we did some cool things with the instrumented bike, like looking at close pass events because we had LIDAR on the bike, so we could look at, okay, at what point, you know, if there's this close pass event from a vehicle close to them, how much does that seem to stress them out? Some of these things that ended up more anecdotal because we didn't get enough events in the course of the study for us to truly say that this was representative in some way. We couldn't run statistical tests and such. But the close pass events that we saw, it was interesting that in Delft, most of the cyclists, just regardless of what type of cyclist they define themselves as, sort of this very confident versus not as confident cyclist, most of them, when asked the question, drivers don't seem to notice cyclists, they disagreed. So even they're having these close pass events and they're not attributing that to the greater driving population. Whereas in Atlanta, people were strongly saying that they're having the same sorts of close pass events, but they felt very different from the driver population. So our conclusions from this, previous studies had addressed stress, but the variables collected were largely defined by the researchers. We were trying to do a study where we were actually asking people, looking at this kind of data, having them self-identify their causes of stress through these interviews that we were conducting. Many of the same components of cyclist stress are things that I talked about previously: presence of motor vehicles, poor infrastructure. In Delft, it was about fellow cyclists. And in both locations, something that kind of got us thinking on our research team was the poor pavement. So I'm going to show you, hopefully I'll have enough time, some follow-up work on that. This supports, again, this idea of building separate infrastructure to minimize the interaction with road users. And cyclists prefer to go at their own ideal speed. They wanted to go a particular speed and not be forced by the vehicles to be going too fast of a speed. So then the piece that we added on to this was we didn't like having to stop them to do their stress survey. We really wanted to figure out a way to do this individually. We initially looked at heart rate monitoring, but there were some other folks doing that, and we were super interested in if we could use eye tracking to do this. I'll give you the punchline of the story is that it didn't work, but I'll show you some of the limited results that we actually got out of this. We're going to turn back to heart rate monitoring because we think it's actually going to be better. But what we were trying to do is to use this eye tracker where we could see the roadway in front, and we could see what was happening on their pupil, where it was looking, whether it was dilating, different things that are supposed to correlate to your stress level. And so we would follow this object up ahead, and we could measure within our frame where are the places that the cyclist would look using this eye tracker. So we could look at X range, so the range in the X direction of where they happen to look, their Y range, so the range in the Y direction, the gaze area, which is the combination of these two things, the median X position, and then their median Y position within all the places that they looked as they were cycling. And we tried to see if any of these things, there's certain studies that point towards some of these as being metrics that would actually indicate that someone is stressed. Things like pupil dilation and such work better. What we found is because it was an outdoor environment, we had a really hard time monitoring these things with the eye tracker that we were using. But we did get some super interesting results around where people were gazing. And this is what led us down this path of looking more closely at pavement. Because when we had sections where it was bumpy or there was a curve or different things going on, we noticed that the cyclists looked down more, that their Y position changed. And so they were paying less attention to all the things happening up front. And it gives you a good indication of the fact that even if they weren't stressed, it could really change the safety perspective. Because if you're staring down at these pavement conditions or the infrastructure in front of you, you're not going to notice that somebody has stopped up ahead and that you're also going to have to stop or whatever the setting. So with this one, with stress, we found anecdotally more stress may mean a smaller gaze area, but we really need a lot more variation in stress levels to understand this better. And we didn't really like some of the metrics that we thought we were initially going to use. The complexity piece was really interesting, though. These bumpy pavements, the complex things, when the task is more important, or the task was more important than complexity in some cases, but in many of these cases, we saw sort of this gaze downward. And then we did try to do some work that I don't have a chance to go into on how skilled they said they were and what kind of a difference that made. So to go on the last one, the other piece that I've been looking at is on actual safety. So these perceptions of safety are one thing, but are we actually keeping the cyclist safe? And so I'm doing a lot of work in this area of trying to get better exposure metrics about how many people are actually biking and walking. How, depending on the roadway characteristics that are out there, can we do these really great before and after studies to understand how crash risk changes and trying to improve crash data that's out there. These are the three things that you really need in order to do things like crash modification factors in the highway safety manual and such. And we really have horrible data in the case of all of these. So we did a meta-analysis at one point in time where we were trying to look at risk ratios from all the different kinds of bike infrastructure that are out there presently. And in many of these cases, there was just not good enough data for us to actually make statements about how good it worked. We could say people prefer them, but do they actually work in keeping people safer? And there were only a few things where the results were really pointing towards it being a good thing. Roundabouts with bike lanes around, not bike lanes, but protected bike facilities around them work. Bicycle boulevards work. So the Portland model of sort of diverting traffic, and even if there's some local traffic, like making that a bike-centric road definitely works. And then we saw, for the most part, cycle tracks. There was actually a fair bit of evidence that this sort of protected bike infrastructure does keep people safer. So I think I'm starting to get towards when we probably want to do questions, but the major findings from that study were that we really don't have enough data to do any of these things well, and we have to be doing a better job at the state and county and city level at collecting better data about actual crashes, about exposure to those crashes, so that we can do these things better. And so the last piece that I wanted to throw in there kind of relates to this actual safety. I'm working with some computer scientists now, and this is a project that's in its infancy, but we're trying to create an app that would actually detect when there was some risk present for the cyclist. And what we've done so far is when a driver makes a right-hand turn, we're trying to create a warning for the cyclist that we believe this driver passing them is about to make a right-hand turn in front of them. And it actually works super well. And so this just kind of gives some examples of how we're actually doing this it's actually sound-based. So we're sending pings from the smartphone to see what the distance to the car is. And we can see already that if it's starting to inch over in ways that you're not going to necessarily detect while you're cycling, we could actually detect that using just a simple smartphone and warn the cyclist. So we're working through this and trying to get this, we call it CycleGuard, to work. So I have papers on that too. And in the interest of time, I'm just going to conclude by saying it's probably obvious at this point, but the things that I've actually learned. So what have I learned in 10 years in all of this cycling research that we've been doing? First, cyclists need dedicated space on higher speed roads. Absolutely true. I think there should be no argument about this at this point, that if we want people to bike places, we have to give them spaces to do so on roads that they would be concerned biking on. Lower speed roads can be mixed, but only if priority is given to the cyclists on those kinds of facilities. And if there's if it's local traffic, lower speed, lower volume roads. Parking is a clear deterrent. So thinking about our urban forms where we're trying to mix in parking with these bike facilities, it does not work well for cyclists. Bicycle infrastructure can help in other ways, like improving air quality. Although again, in our air quality studies, we were seeing that commercial was a bigger determinant of the poor PM 2.5. The quality of roadways matters. So things like pavement, when we look, many of the folks who work in pavements in my field of civil engineering, they're often thinking about the drive that cars have, the experience that cars have. And there are different types of pavement failures that make a very big difference for cyclists. And we did a whole additional study looking at what should we be concerned about in pavement design when we're thinking about the cyclist experience. And then to understand the intricacies of all of these designs, we need many, many more before and after, because we try to do this in really broad perspectives as academic researchers. But every time we design this in the real world, there are so many intricacies to how we design that we need a lot more information to say what works well and what doesn't. And then again, lots more data on things like, so we can get to actual safety and not just perceptions of safety. How well we can understand these things is very dependent on having better data than what we have today. So with that, thank you. I tried to leave at least a few minutes for questions.
Curious, for some of the other countries like the Netherlands who have more bike infrastructure, do you see that some of their, they have more data and recording of things around bicycle safety for crashes to determine some of those decision making for bike infrastructure?
So I haven't worked much with their crash data to know how much better of a job they do than we do. One thing that's interesting though is you can look broadly, I mean, because we do know when crashes are occurring in all of these places, right? It's just some of the difficulties, like you can't do a crash rate if you don't have that exposure part of the metric. But in the Netherlands, their crash rate overall across all modes is much, much lower than in the US. So they've provided this vastly safer general transportation system there. And that plays out just in looking at like their death rates or their injury rates and crashes and things like that. One thing I will tell you that they do super well is we created an app at Georgia Tech called Cycle Atlanta that tracks where people are traveling. So it does like we could do like route choice models and things like that from this. And in the Netherlands, they have one that they have like bike week once a year, and they have all these people record their trips in their national app that they've created. And they get so much rich data about, where is it that people are cycling? How are they using it? Things like that. So, yeah.
Can you get data like that from Strava? Like, is that?
We have tried. Yeah. So that's one of the things. I have a student right now who's working on that, and we've tried it in the past. And there's a researcher at the University of Santa Barbara who has done tons of work in this area. Part of the difficulty is that Strava is many more sport cyclists than kind of your typical commuter population. And so trying to correct for those biases, because some of those sport cyclists will be more of that strong and fearless population. So they're going to be willing to bike on roads that I might not, because I'm not that kind of cyclist. And so trying to correct for that. But at this point, we've got methods to correct for that. So we can use things like Strava to get a pretty good idea of bike volumes. Yeah, great. Yeah.
Related to Strava, given that many of us these days wear heart rate monitors on ourselves all the time, do you see any move towards being able to harness this sort of data that people just create while they're commuting or such for the sake of seeing bike facility or land use associations with heart rates as a way of measuring stress events?
So that's exactly what we hope to do as the follow-on to the instrumented bike study, is that because the eye tracking didn't work out, we sort of had this opportunity to try the eye tracking. We're going to go back, and there are some people who have already looked at this using heart monitors. One of the interesting things that we want to do, though, is try to do exactly what you're saying, where if we can actually put some of the instrumented bike functionality just into a smartphone, it would be much easier to vastly change the scope of the study we're doing. We don't need to like take this box and put it on every person's bike, right? And so if you have an Apple Watch or whatever, and you're monitoring, and you've got an app you're willing to mount on the front of your bike, then all of a sudden you can be a participant in our study, no matter where you live and whatnot. So that's exactly what we're looking to do next. One of the things, I think at least one of the students, I don't think she's here, but the equity implications of that are a little bit hard though, because we've thought about, are we only measuring a certain portion of the population? And like, will we end up sort of making some conclusions that are not necessarily representative of the full population? So we're trying to figure out smart ways to do that so that we can take that into account, that maybe we recruit some cyclists and we give them the Apple Watch for a certain period of time or forever, right, to enter the study.
I'm going to say that just between Garmin watches and Apple watches, you might get the population of the people who clearly like exercise enough to buy a Garmin versus
the general
public.
By the way, if you all could continue, I've got to duck out.
Yeah.
Continue and
Well, maybe we can officially end here, and I'm happy to stick around and take
whichever.
questions.
Dolores and Kari, you have the calm.
Thank you all so much for having me.
Thank you.
Very good.